The next great power contest will not begin with an oil tanker or a battlefield. It will begin inside a battery, a semiconductor, or a missile guidance system, and the nations that control the minerals powering these technologies will wield extraordinary economic, technological, and geopolitical power. Critical minerals are materials essential to modern economies and national security, difficult to replace and vulnerable to disruption. Lithium, rare earth elements, cobalt, nickel, graphite, copper, gallium, and germanium now sit inside smartphones, electric vehicles, wind turbines, satellites, radar systems, advanced chips, fighter aircraft, and precision weapons. They may be invisible to consumers, but they're becoming brutally visible to governments. The green energy revolution is accelerating this race. Global electric car sales exceeded 20 million in 2025, representing 1/4 of new cars sold. Battery deployment across all applications increased more than six-fold between 2020 and 2025. And an electric car requires roughly 6 times the mineral inputs of a conventional vehicle. That means every EV target, renewable energy plan, and grid storage project quietly creates another mining, refining, and logistics challenge. The International Energy Agency expects demand for critical minerals to almost double by 2040 under existing policies, with lithium demand rising more than threefold. Yet supply is not keeping pace. The IEA projects a 25% copper shortfall in 2035, alongside a continuing lithium deficit. The clean transition is therefore not simply an engineering project. It is a geopolitical bidding war over finite deposits, processing capacity, infrastructure, and political influence. National security makes the stakes even higher. An American F-35 requires more than 900 pounds of rare earth materials. Rare earth magnets are also used in Tomahawk missiles, smart bombs, drones, submarines, and radar. Gallium and germanium support semiconductors, sensors, communications, and aerospace systems. A country unable to secure these inputs may possess brilliant weapons designs but lack the materials to manufacture them at scale. This is why critical minerals are becoming the oil of the 21st century. But the comparison is incomplete. Oil mainly powered machines. Critical minerals enable the machines, networks, weapons, and digital systems through which power itself is exercised. China understood this before most Western capitals. It does not merely mine minerals. It dominates the expensive, polluting, technically demanding middle of the supply chain. China is the leading refiner for 19 of 20 strategic minerals tracked by the IEA, with an average share near 70%. In April 2025, Beijing imposed controls on 7 heavy rare earths. Wider restrictions followed, exposing how quickly industrial dependence can become strategic vulnerability. By 2035, China is still projected to supply over 60% of refined lithium and cobalt and around 80% of battery-grade graphite and rare earths. This concentration is not an accident of geology. It is the result of decades of industrial policy, subsidized infrastructure, technical expertise, and Western willingness to outsource dirty processing and environmental costs. That shock is driving a new resource race. American, European, Japanese, Indian, Gulf, and Chinese capital is competing across African copper and cobalt belts. Latin America's lithium triangle, Central Asian deposits, Australian mines, and Arctic prospects. Diplomacy is increasingly traveling with geologists, financiers, and security officials. Mineral partnerships are becoming alliances, processing plants are becoming strategic assets. Pakistan has a narrow but serious opening. Reko Diq contains probable reserves of about 7.3 million tons of copper and 13 million ounces of gold, with first production targeted for late 2028. OGDCL has also reported lithium in formation water in Sindh, with concentrations it says are comparable to lithium-bearing geothermal brines being commercially developed in parts of Europe and North America. The finding is potentially significant, but it remains an early-stage indication rather than proof of a commercially viable lithium reserve. Geological exploration in Balochistan and the northern regions also points to wider mineral potential. But exporting concentrate will not transform Pakistan. The real prize is refining, processing, skilled employment, component manufacturing, transparent contracts, reliable power, and local infrastructure. Without those, Pakistan will surrender the value chain and keep the environmental burden. The world is not escaping resource dependence. It is changing its chemistry. The winners will not be countries that merely possess minerals, but those that convert geology into industry, industry into technology, and technology into power.